give my call after this. All right. So while that's going on. All right. So these are a list of non-metals. So if you know these, then you know the covalent bonds automatically. Because when two or more non-metals combine together, all right, to form a single compound, then that is covalent. So we have nitrogen here, and we have oxygen and fluorine. All of these are non-metals. All right. So, and look at them. It's not many. Very few non-metals. Just take out a part of the periodic table. These are all the non-metals on the periodic table. The ones that are lower down, these are some of these could pass for metals in some ways, because for example, if you look at antimony, which is down here, that's number 51 here. Antimony looks like a metal. You couldn't tell that it's not a metal. All right, couldn't tell that it's a non-metal at all. In fact, let me show you what antimony looks like. Actually, they use it as a poison actually, but you know, can also be used to make bullets as well, certain type of bullets. Almost look like, you be the judge of this still. Antimony is a nice picture of antimony here. All right, I'm going to show you what it looks like. Everybody seen this?
Yes, sir.
That's antimony. Yeah, so that's antimony there. All right, so that's antimony. And then it looks, as you say, if you look at the characteristics of non-metals, they're supposed to be, they're not supposed to be shiny. But yeah, this is shiny. It can conduct electricity to an extent. It behaves somewhat like a metal, but it's different. But if we look at the ones at the top though, like the ones in a bright green, these are classic non-metals. The ones in the darker green, and it's actually color code here. The darker green ones, so like boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Those are close to looking like metals. All right. The ones in bright green are actually non-metals. They are full non-metals. And of course, over on the far left, far right hand side rather, we have fluorine and chlorine. These in red. I think because these are colored in red because they are gases. So the reds are gas. Red means they are gas, and the black here means they are solid. Right? And the ones that are solid are close to being metals. Right? I think what they have here for phosphorus, however, is, well, this is in light green. But these are classic non-metals. They don't have any metallic behavior whatsoever. Um, so I think the scheme here is that the black, when they are written in black, they are solids, right? You're seeing that here. When they are written in red, they are gases. Boron, sorry, not boron, but bromine at 35, if you're looking at this part here. This is a liquid, so it's in blue.
Yes, sir.
Right. So this is powerful information for you guys. Whether you accept it or remember it, that's up to you. But you know, I think that as a student, you should try to remember things because when you're young, it's easy to remember things. Uh, It's just that fact. So you have to make the most of your memory because your memory is going to fade as you get older. And then, you're going to wish you were young again. So make the most of it. Try and remember the thing, them. Get used to the thing and be able to do it because this is all coming out of the CXE syllabus.
Okay, sir.
Yeah. All right. So those are non-metals. So that's solid. Bromine now. What does bromine look like? No, CXE asks questions about bromine every now
I
and then.
think it's a reddish brown liquid.
Very good. Have you seen it before?
Yes, sir.
All right, where you see it?
Sir, when I was studying the halogens, the
Oh,
trends in the halogen group.
we did that now. Yeah. Um, definitely, definitely. That's so true. All right. So and for those of you who not so fortunate to study the halogen group, here's what bromine look like. Right. Um, this is bromine here. Let's probably put it here, and that's bromine. All right. So seeing this Terian sachet.
Yes, sir.
All right. It's bromine. All right. So bromine can exist as a liquid or a gas. If the temperature is cold, then it will stay liquid. If the temperature is warm, then it will become a gas. So that's how bromine behaves. All right. Let me probably send this back. There. All right. So that's that. So that's a non-metal. So again, why we need to know non-metals is for this objective here. We predict the likelihood of an atom forming an ionic or covalent bond based on atomic structure. All right. The other these are non-metals. So we have hydrogen, oxygen. All of these here are non-metals banded together. All right. So once you know them, then you have no problem. So know the non-metals and the periodic table. All right. Now, all right. When two are more, when two or more non-metals combine, chemically, because they can combine physically, but when they combine chemically to form a single compound, all right, to form a single compound, then see what's happening here. All right, to form a single compound, the compound is a covalent. All right, the compound is described as being either molecular or covalent. The compound is covalent. All right. The compound formed is covalent are described as being molecular. So that's what you do now. Look at a compound, and that's how you predict the likelihood then of this substance being a covalent or ionic. Let's see if I can move this over here. And if I can convert this to text. I just have an intertext function there. Hopefully it works. If it doesn't, then so it is. Yeah, all right, cool. Not bad. All right, so there you go. I think the font got messed up, but that's okay. Can always the compound is covalent or put that there. This is space that. But change that afterwards. All right. So two or more non-metals combine chemically to form a single compound. The compound is described as being covalent. Right. Let's put formed up here. Covalent. I wanted that to be in caps, but let's put that in bold. Underline. Or molecular. All right, let's underline that one. All right. So basically that's the story. It's so in order to understand covalent compounds, just know your non-metals them. If you see two or more of them together in a compound, then it is covalent, or you can call it molecular. Which is it there in the syllabus specifically? Let's go through the objectives. All right. So what we just did was just 5.2, which is predict the likelihood of an atom forming covalent or ionic compounds. Write the formula to represent ions, molecules, and formula units. So write the formula to represent molecules. So if we're gonna do that, then it's covalent. Once I say molecules, that's covalent. All right. No, I think we looked at metallic bonding. You have notes on that?
No, sir.
In the metallic bonding?
No, sir.
It's interesting. It's interesting indeed. All right. Well, if you didn't do metallic bonding, we're going to have to revise that. But certainly for the non-metals though, and let me just write common molecules, and this is for CXC purposes. All right, common molecules. Molecules, and this is molecular compounds. Yeah, that's what it's called. Now, and I'm looking at what they have asked in exams over the years, and what is common to most persons. All right. Number one on that list though, I'm definitely going to put water there. That's the most common one. All right. Second one is NH3. And if we go through several years of past papers, you're going to see how many questions they ask about water and ammonia. These have to be like in the top, well, if not certainly not the top two, but certainly like the top five that they ask about these compounds. Carbon dioxide is pretty common as well. All right. And extremely common. As in from water, and this one is water, so as you would know. The reason I leave some space beside it or even below it is that we need to be able to describe things about these compounds. For example, for water, they could ask you how to test for it. Right? They could ask you they could ask about the properties of water. They could ask you to draw the band. So I'm actually trying to craft some possible questions out of this activity here. Writing the common molecular compound in CSEC chemistry. All right, that is goal for you guys. So water, we have ammonia. All right, we have carbon dioxide. All right, and that's like right now, just off the top of my head, that's really the top three. We have methane, which formula for methane is CH4. This is a popular one. All right, and we're talking about common molecules here. So, and even this one, which I expect everybody to know this one. Which one is this?
Sir, glucose.
Okay, glucose. Very good. So glucose indeed is correct. All right. So
Sir, would nitric acid be one?
mm, molecular compound. No, nitric acid is it's actually an ionic because um it is formed by two ions. No, yeah, that's a good question, because you'd have to understand what happens in to make nitric acid. Nitric acid is really a combination of this component I'm going to write here, right? Which is, what's this one? What's the name of this compound?
Nitrate.
Can be nitrate. That's all the name it.
Nitrogen oxide. Nitrogen dioxide.
Yeah, nitrogen. All right, so hope Terika and Sashi is understanding and listening. Nitrogen dioxide, di means two. When we're naming covalent compounds or molecules, we use we use a prefix di if it's two of the molecules there. So like this is saying NO2 is really saying one nitrogen atom combining with two oxygen atoms to form a single compound. When that happens, the formula is written like this. The name of the compound is nitrogen, which comes first, and di, which is telling you how many of the other thing is coming. Oxide is the name of the other thing. And so the name of the compound is nitrogen dioxide. And that's it. So these are common, very common questions here for CSEC purposes. And how could I also forget this one? So you were asking me about nitric acid now, Kimberly. So nitric acid is simply a combination of nitrogen dioxide and water. It's a combination of those two things. Now, what happens? They actually react together. And it forms, when those two things combine, it forms what they call the nitrate ion, right? Because you have so nitrogen is NO2, but then when nitrogen oxide combines with the water, somehow this oxygen gets stuck onto the nitrogen dioxide. So it forms a nitrate ion, right? And then when it forms the ion there, it does something called polarization, meaning that it puts stress on the bonding between them, and so it becomes charged, and so that's how acids are formed in that way. All right, so acids, even though most acids would look like it's covalent, the fact is, with the hydrogen being there with more reactive elements, it's going to have an ionic behavior. So that's one of the things in chemistry that you have to understand. It come in like some words in English where it don't pronounce the way like it's spelled. If you understand what I mean, you know, same thing in chemistry. Um, so when we talk about acids in a later class, then you see what I mean. So it's actually a good question. Well, let's complete this one. This is sulfur dioxide, very commonly used in CSEC exams. All right, so and there you have it. This is like random seven, but seven common critical molecular compounds that you need to know the formula of and need to know a bunch of things about them. All right. In fact, for each of them, you should be able to tell me 5 things about it. You're supposed to be able to tell me about the bonding. All right. So for these now, all right. So what type of bond? Is there a question? And what type of bond? Of course, because it's molecular, automatically that's a giveaway. Um, what type of bond is present? All right. That's the first question. All right. And then you're supposed to be able to answer now how describe a test in the lab for each. All right. Describe how we can test for the presence of these?
Sir, how would you do that?
Well, so good question. So there, you could look at it. You can approach it two ways. You can sort the list that they have. There's a list of how to test for these, which I could show you, and then you try and learn that. That's one way. The other way is, you know them. So let's look at those individually. I can send you the list of those in this after class. All right. How to test for each of these here. All right. But then you still need to know that. All right. And yeah, and guess what? How to prepare. Describe. So you're going to also describe how we can prepare, how we can prepare these, prepare a sample of these in the lab. In the lab. So, and finally, draw the atomic structure of these. So yeah, that's just random questions. So all right, so these are a must know for CXC. All right, and as I say, in a future class, if I just randomly take past papers, it will be easy to find questions asking you these same questions I'm asking you here in class. All right, so you guys, as we say, I give you what you need is for you to take it and run with it. But you can't just take up chemistry at class time alone. All right, so that's it. That's the idea here. As for that list now, Kimberly, I'll send it since we reach the end of class officially. So I'm gonna send the notes. All right, and you can actually see it there. Let me just so yeah. So you have any questions? Any other questions?
No, sir.
All right. So all right. So now that's it. This is testing for well these would be all right non-metals. Non-metals is actually a part of the syllabus by itself too. Well, for gases, testing for gases, you would say, because many of these are gases. And all right, a few of them. Quite a few of them are there. All right, so I'm gonna send this then. Yeah, let's send that. Let's see who we have here. So oh, Sashi drop off. Yeah, that's cool. That's cool. Um, all right, guys. If you don't have any questions, then I'll just send this in the group then, and you can have it to look at. All right.